Hey students, we're going to continue on our list methods now. The previous video was on list functions, which are native functions. Methods are specific, mini functions which have to be attached to the object. And since we're dealing with list objects now, all of these methods will always include the dot. That's how you know it's a method. Like look at the length function that operates on a list. Given a list here, if we give A, well then, the argument is the list. That's going to be different on the list methods, where we will need to provide the list name and then a dot and then the method name, and then of course any arguments there. So that's just a refresher on the difference between a function and a method. So we're going to look in this video at the various list methods that we'll be using throughout this course. Of course, dot append is quite easy to understand and easy to create. We just simply provide a value here, and that appends that value to the end of the list. Clear is quite easy. It does exactly what you expect. It clears out the list. It doesn't delete the list, interestingly. It just clears out the elements so that you have a list of size 0 with no elements in it. Pretty straightforward. Now, extend is cool because in the parentheses, you can actually include a list. And what this will do is take the original list and append another list to it. Now, this is important because if you want to append a single value, you just use the dot append method. But if you want to include multiple values in that append operation, well, then we just use the dot extend method. We first have to create a list of the new items to be appended to the original list, and then we just use extend to bring that. So extend will take a new list name. Insert does exactly what we expect. It'll insert a specific element at a certain position. So the arguments here necessary are, of course, the index I, where are we going to place it? And then the value. And what that does is, if this is our list, it's going to insert that value right here. And then all of the other elements will shift over one to the right because we have that new element right there. Remove does something a little bit similar. It doesn't remove it by index, but it'll remove it by value. And what Python does for .remove is, and this is important to remember, it just removes the first instance of that value. So we'll see in my demo code in a second where I've got a bunch of 13s in a list, and I go ahead and call remove 13, and it just removes the first instance of it. Meanwhile, this 13 and this 13 and so on all remain intact. Count takes a value as its argument, and it'll simply return the number of elements that are equal to that value. So like if I did count of 13, it might be 3 or 4, whatever I had in the list. It just gives us the integer of the count of that variable, of that value, I should say. Now, index is interesting because it will sort of do a reverse search, a reverse lookup. Given a value, and that's exactly what we provided, it will return the list index of that value. And that can be important if we're doing some advanced manipulations, or if we need to output our list in a certain way. Now, pop is going to do a number of things. First of all, we provide it with a value, and what it'll do is it'll first actually return that value. So it'll return it to the console, or return it to a variable assignment operation that you might want to do. But then the second part is important because it removes it from the list. It's sort of like if we remember from our C++ experiences, vector pop operations, how it will return that last value and then boop, it's gone off of the vector. Pop is going to do the same thing for us. As expected, sort will sort a list and reverse will reverse a list. So given all that, let's go now and take a look at some sample code. So let me bring up my Python. Okay, and here is a good number of just kind of demo snippets of code. And this, of course, is posted right below this video link. You'll see this exact code. So if you want to pull it into your IDE and then experiment and play with it, then I really encourage you to do that. All right, so first, here is my original list. It's just got a bunch of numbers in it. However, it's got 13 listed 3 times. And I do that just so later we can kind of play with, you know, the first instance behavior with Python. All right, the first thing that we wanted to look at in our grand list was append. And if we append the value 24 here to this list, it will simply output that same old list ending at 85, except now we have a 24 attached to it. Now, this next little segment of code here, it answers the question, well, what if we want to append more than one value in a single operation? Well, it's easy. Just create a list of the new values. So here's my new list B, and I'm just going to insert a bunch more values there, 5 more values. And then I will call extend. I'll call extend on A and provide list B as the argument. So it's just going to take list B and append it to list A. And now we have this giant list for A. And you can see there what the output is. You know, if we run this, and let me run it real quick. You can see that we're getting that output now. Okay, next we want to look at, well, what does clear exactly do? So what I'm going to do is create a new list C that is a shallow copy of A using the index slicing method that we looked at earlier. So this creates a shallow copy that's complete. And since all of these are the same data type integers, it's tantamount to a deep copy. So we can be guaranteed that this is a truly representative copy. We can manipulate C, and index A here stays intact. So this is just sort of proof of that. If I print C now, it's going to print out this entire list that was copied to it, and this was the original list A. And then you guessed it, if we call C.clear, it's going to clear out all of those elements. And if we print out C, it will actually print out the empty set, which is just open bracket, close bracket. Nice and simple. We can call length on it, and the length would be 0. Okay, our next segment of code looks at insert. And remember, insert will take 2 arguments. First is, what is the index at which we're going to do this insertion operation? And then second, what's the value? What are we actually going to insert? So here, you know, in my A array, in the 5th element, great movie, by the way, The Fifth Element. Any fans out there? Any fans? Message me. Maybe we can watch that for one of our classes. All right, it's going to insert as the 5th element this float. So we call that, and then if we print A right away, then we see that, yep, there is that new float there. And then let's count, make sure that's position 5. I'm sorry, position 4. 0, 1, 2, 3, 4. Okay, so it did insert it at the right location. Now remove, we have to remember that's going to be one of these methods that operates on the first instance of a match between an element and a search term. So here, if we call a.remove and give it an argument of 13, it's just going to remove the first time it finds 13, or in our language, the first instance of 13 in this list. So if we remember before, 13 was the first element of the list right here, we call a.remove, and sure enough, now it outputs all of this, and that first element 13 is missing. So again, it's a reminder that just the first 13 gets removed. Here's the second, oops, here we go. Here's the second 13, and here's the third 13, and those are both intact. Okay, knowing that we've got two instances of 13 now, well, we can call count. And a.count will return the count of that variable or elements that match that search term. So it'll go through and say, okay, what elements are 13, total those up. And in this case, we will get a 2 for the output because we've got two 13s still in our list, okay? Now, what's interesting is dot index will do the opposite. Rather than providing a value and it returns an index, we're going to do the opposite. We're going to, rather than it providing a value and a count, well, we're going to this time provide a value, and it is going to return the index number of that value. And then again, here is where we have that same first index situation that comes up again. Because if we have multiple values of 13, well, it's just going to go through the list until it finds the first instance of 13 and then return that index number. So here in this case, we're going to print out whatever gets returned here, and we have a.index 13. Now remember again, because it's dot index, it's going to return the index value of the first 13 that it finds. And if we remember up here in sort of our new array, or the most current list here, 13 is in the third index or third position, which is index 2. Here we also take a look at, all right, great, where is 35? And it'll output 5 here, 0, 1, 2, 3, 4, 5, right there. All right, next up is pop. And pop will again, it'll return whatever value is that at that index number. So the argument is an index. It'll return whatever we get from it. So if we want to print it or assign it to a variable like popped value, whatever we need to, it will return that. But then it removes it from the list. It yanks it, we examine it as a return value, and then boom, it's off the list. So here, again, remember that 5 is the index. Let me actually print a first here. So here is what a currently is. And after we pop the 5th element, and let's count, and let me expand this a little bit. After we count the 5th element, 0, 1, 2, 3, 4, 5. So 5 is going to get removed, and then we pop it off, and we can see here in the resulting list that we have no 35. We skip right over it right here. It used to go 96, 35, 13. Now it just goes 96, skip 35, and 13. So that's showing that it did get returned and popped. Okay, and then dot sort will do exactly what you think it is. It'll do an in-place sort of the list just with a dot sort. There are look at the book. There are some arguments that we can place within that sort method, the dot sort method, I should say, including if we want to reverse it or not. So here, if we sort it, there we go. It got all the values sorted. And then, similarly, the dot reverse method will do an in-place manipulation of this list and just swap the elements, go back to front. And we see here that that output does in fact hit all of those and just simply reverse them all. So that's hopefully a good primer on all of these methods. And I think that the code that I post in Canvas, with all of this here, will definitely help you, and absolutely go through it carefully, especially for this week's assignments, of course, but then for overall comprehension of this module. So hope it helped clearing up these, what were these, 5, 10, 11, 3, 4, 5, 6, no, 10 methods that we examined for list methods. Okay, thanks everybody.